Assalamualaikum warahmatullahi wabarakatuh and good day to everybody. For today, we are going to continue from the previous lab 3. So this is a lab 3 part 2. View the switch MAC address table. Please make sure that you have your packet tracer from the previous lab activity ready for this new activity. So the objective of this activity is that 1. To build and configure the network which has been completed from the previous part, and then the second part is to examine the switch MAC address table. The purpose of the layer 2 LAN switch is to deliver Ethernet frames to host devices on the local network. The switch will record the host MAC addresses that are visible on the network and maps those MAC addresses to its own Ethernet switch ports. So this process, mapping the switch port to the MAC address, is what we call as building the MAC address table. When a switch receives a frame from a PC, it will examine the frame source and destination MAC addresses. The source MAC address is recorded and mapped to the switch port from which it arrived. Let's say a frame comes from the PCA and then it will reach to the S1. S1 will build the MAC address table with the PCA MAC address and then map it to which port that the frame comes from, which in this case F06, like we have put inside the topology in the packet tracer. Okay, so after that, if the destination MAC address, it looks for the source MAC address, okay, and then after that, okay, the destination MAC address is looked up in the MAC address table here. So the destination MAC address is looked up in the MAC address table, and then after that, if the destination MAC address is a known address, means already inside the MAC address table, then the frame will be forwarded out of the corresponding switch port associated with that MAC address. If the MAC address is unknown, means that it's not recorded yet, then the frame is broadcasted out of all switch ports except the one from which it came from. It is important to observe and understand the function of a switch and how it delivers data on the network. The way a switch operates has implications for network administrators whose job it is to ensure secure and consistent network communication. Switches are used to interconnect and deliver information to computers on the local area networks. Switches will deliver Ethernet frames to host devices identified by network interface card MAC addresses. That's the reason why we categorize the switch as a layer 2 devices. Let's continue with our activities. Now, because we have finished building and configuring the network from the previous activity packet tracer, now we will continue use the same packet tracer activity and do the exercise for part 2. Let's continue with part 2. In part 2, we will examine the switch MAC address table. Here, a switch will learn MAC addresses and builds the MAC address table as network devices initiate communication on the network. We will, before we start to check on or examine the switch MAC address table, first we need to record network device MAC addresses. So for the first step, open the PCA, open the command prompt, okay, and then okay, now usually your content will be empty. Now if it's empty, means that there is no information yet, right? Now open a command prompt and type ipconfig/all. So ipconfig space /all, and then Now, look at the first output. Okay, so first output is the fast Ethernet, and then there is some physical output that write physical address, right? This is your MAC address for PCA. Select and right click copy and then paste it, right? So do the same thing for your PCB. Okay, type ipconfig space /all. Okay, and then select, copy, and then paste it. Okay, next is that console into switch 1 and switch 2 and type the show interface F01 command on each switch. So go inside the console CLI, right, enable, and then show interface F01. Now, okay, on the second line of command output, what is the hardware addresses? So we are going to find what is the hardware addresses. Here on the second line, fast Ethernet 01, hardware is LAN's address is 00E0. Or you can find the burn-in address with the keyword BIA. So both can be used. Now this is your MAC address. You select it and then you copy. And then you need to paste it on your answer sheet. Now go to the switch tool. Open your switch tool, command line, console. Okay, enter, enable. Now show interface F0/1. Okay, so look at the hardware address 007 EC18C501. Click copy and then paste it. Okay, now we are done with the recording of the MAC address table. We are going to display the switch MAC address table. So look into or open the console of switch 2 and view the MAC address table both before and after running the network communication test with ping. Means that before you ping to other devices, we need to look at the content of MAC address table. So you type on the privilege exec mode. So you type show MAC address table. So I just type a short form sh MAC must be full, and then address ADD also can be identified. So the command should be show MAC address table, and then I press enter. Okay, you can screenshot for this figure, for this output. Okay, you should be able to see it's MAC address that is recorded in the switch 2 has only one output. Now so even though there has been no network communication initiated across the network, we did not do the ping yet, right? So it is possible that the switch has learned MAC addresses from its connection to the PC and the other switch. So when we look at this, okay, you can match it to which MAC address that it is belong to. So E0E339, okay, you can look at S2, no. And then 00E0A339 belong to switch 1 MAC address, which is mapped to FA01. So in this case, in which FA01 that we refer to? Okay, remember, we are looking inside the switch 2. Okay, so switch 2 can recognize that the connections of switch 1, okay, comes from switch 2 FA01. So in this case, It comes from FA01 port in switch 2. Alright? Okay. Now, are there any MAC addresses recorded in the MAC address table? No. Okay, so what MAC addresses are recorded in the table? To which switch port are they mapped and to which devices do they belong? So as I have mentioned before, when you look at the one that you have recorded, so it match to switch 1. Okay. Okay, so if you have not previously recorded MAC addresses of network devices in step 1, so how could you tell which devices the MAC addresses belong to using only the output from the show MAC address table command? So does it work in all scenarios? So the output can be different. Okay, so the output of the show MAC address table would shows that the port that the MAC address was learned on. So in most cases, this would identify which network device the MAC address belongs to, except in the case of multiple MAC addresses associated to the same port. So this will happen when switches are connected to other switches. So in this case, switch 2 is connected to switch 1, okay, through the FA01. So in the case there is some multiple port of FA01 identified or input in the MAC address table, so means that there is some other computers that is connected to that switch, and this switch is connected to the current switch. Alright. Now, what do we need to do? So we need to clear the switch to MAC address table and display the MAC address table again. Okay, so let's say you accidentally ping. Now we want to erase the content. So go back to the console of the switch 2 and type clear MAC address table. So I would press tab, and then I would type dynamic. Okay, now once I have pressed enter, quickly type the show MAC address table command again. So use the previous history command. Now you can see that there is no MAC address table appear in the console. Sometimes you will have a different output. Okay, so most of there's a possibility that you will discover that MAC address of other switch also can be quickly reinserted in the MAC address table. Alright. Now, let's wait for 10 seconds and type the show MAC address table command and press enter. So I believe that it is more than 10 seconds. So we issue the command show MAC address table again. Now see, the same MAC address from the switch 1 appear on the MAC address table. Okay. Now go to the step B. From PCB, ping the devices on the network and observe the switch MAC address table. We open the PCB. Okay. Command prompt. Now, open a command prompt and type ARP-A. So, ARP space bar dash A. Make sure there's a space. Enter. Now, not including multicast or broadcast addresses, how many device IP to MAC address pairs has been learned by ARP? So you capture the output. Actually, no ARP in my window. So the answer will vary because of the ARP cache may have no entry on it or may have the gateway IP address to MAC address mapping. Now, because this is empty, so we can proceed to the step B. So from the PCB command prompt, ping PCA, switch 1 and switch 2. So I would do for the PCA, and then you will continue. You will follow with the ping PCA, ping switch 1 and ping switch 2. Alright. Now, what is the PCA IP address? Look back on the addressing table. So you ping 192.168.1.10. Okay, now let's go back to the previous step. Okay, did all devices have successful replies? You look back. Did you get a full reply? Yes. But if you did not get a full reply, then you need to troubleshoot. Okay, you need to troubleshoot the cabling and the ports, okay, and the IP configurations that you have made on your PC and also your switch. Right, now assuming that you got the reply, okay, so go back to the switch 2, right. So this is my switch 2. Again, I would issue the command show MAC address table. Okay, now you have 3 inputs. The previous one is from the switch 1, right? So comes from FA01. Now there are 2 new inputs. Okay, so which MAC address belongs to which PC? So let's look back on your previous record. So look at PCA is A.F320. So this one, the second on my console, this is on the second record. And then PCB is 0019763, which is for the first record. So which port does the MAC address PCB map to? FA018, right? This one. This is this is my PCB, which is connected to the switch through the port switch FA018. And PCA is connected to the switch 1 from FA06. Now, you might be wondering, why is the PC1 from this MAC address, okay, comes from the ports FA01? Remember, you are inside the switch 2. Switch 2 only knows the frame from PCA, okay, will come from the switch 1, okay, and then enter to the switch 2 FA01. So it only know where does the port in switch 2 comes from. That's it. So that's why this is where the condition happens, where, okay, there is 2 records with different MAC address but sharing the same port. Okay, because one is a switch, okay, that is directly connected to switch 2, and then the other is another PCs, maybe 1 or maybe 2 or maybe more, okay, that is connected to the switch 1. Okay, so they are coming from the same input, okay, port input. Alright, so let's go to the next part. Okay, now, okay, we will look at PCB. Go to the PCB. Okay, this time retype ARP-A. Right, so as you can see, okay, does the PCB ARP cache have additional entries for all network devices that were sent from the pings? Now, if you look at this 192.168.1.10, okay, that is the IP address that you ping to the PCA, right? Now, okay, the entry will record, the ARP will record the IP address, okay, of other network devices that is previously has been communicated, okay, through the ping, right? So, and then the second column, they would record the MAC address of that IP address. So in this case, PCA has IP address and then also MAC address. So to initiate the communication, previously we don't have the MAC address. Okay, PCB doesn't have the MAC address of the PCA, but now after the initiation, okay, they can learn. They have learned what MAC address belongs to the other network device like PCA. That's it from me. Thank you.